Hi, today we're going to talk about radiology and x-rays. So I chose this topic because it is something that I work with every day. I'm a vet assistant at two different practices, one that's small animals, so like cats and dogs, and the other that is equine. And what's really cool about this job is even though it's the same like medical modality, you use it in a very different way for both sets of animals, the small animal and the equine. So with your horses, it might look a little bit like this, where you have someone holding the plate or it's leaned against the horse, and then you have someone with a portable generator taking an image. And then with small animal, you might have something that looks like this, where the dog is laying across the table and might be held up by some sandbags or some towels to get that best image. And going back to talking about using the radiographs or the x-rays to look at very different things for your small animal and your equine, some of the common reasons even differentiate quite significantly. So in your small animal, you might be looking at like your lungs, you might be looking at congestive heart failure or the heart size and placement, or you might be looking at, for dogs, foreign body, and for horses or other large animals, you might be looking at a hoof and some bone structure, looking at locomotion, those kinds of things. Okay, so let's talk about x-rays, how the x-ray itself is formed, and then also how the x-ray image is formed. So radiographs are the fancy name for x-ray images. And x-rays are a form of electromagnetic radiation. They have a very short wavelength, high frequency, and high energy. You might have seen something like this from your middle school or high school textbooks. We are usually familiar with this spectrum when we're looking at visible light. So to have a comparison, 400 to 700 nanometers is for visible light wavelength, while x-rays are about 10 picometers to 10 nanometers. So they're significantly smaller. So how is the x-ray formed? So we have the generator, and x-rays are formed by accelerating or decelerating charged particles. In the generator, you turn your current on. You have electrons moving from your negative source to your positive end at a very high speed. Now, the electrons are attracted to the positive end because electrons are negative, and when the electron hits that positive end, it has so much high energy and speed that it will collide with another electron. Now imagine that in an atom you have your center and then you have rings. So you have inner rings that are closer to the center and you have outer rings that are farther away. When the electron collides with the other electron, the electron that it is colliding with is in the ring that is closest to the center. So electron comes in, hits the electron that's on the innermost circle, and that electron that it hit, it transfers all its energy and it goes, pachoo, it's gone out of the atom. Now, when this one hits this area, now there's an empty spot on this innermost ring, so the electron above it and the next closest ring will jump down to fulfill that role. When it jumps down, a X-ray is produced or released. So that's how you get that. It's essentially in the collision of electrons that you get that release of the X-ray. So with forming the image, the actual image of the X-ray that you and I are most familiar with, the X-rays are aimed at the body and they're shot at the body towards an X-ray detector on the other side. And the x-rays will pass through things that are less dense, like air and soft tissue, but they will be absorbed by things that are more dense, like bone and metal. And that's how, once they come through the body and they either pass or absorbed, and then they end up on the other side, on that photographic film, that's where you get those differentiations in the color. Your black is going to be air, your gray is going to be your soft tissues, your white is going to be your bone, and your bright white is going to be your metal. So kind of looking at the influence of X-rays in general evaluation and practical application of everyday society. Yes, absolutely. It is critically influential. It is one of the most common medical modalities for diagnostic imaging. We see it at the airports, we see it at the dentist, we see it in veterinary medicine, we see it in human medicine, whether sports or general. And then also looking at kind of where we are looking at the grander scheme of just the knowledge base and physical applications. Stark 2023 says it's really important to continue to learn about electromagnetic radiation in its different forms, including X-rays, because it has so many grandeur implications with not only physics and more complex physics, but chemistry, reactions, and biological processes. It's all integrated. And looking at the future technology of the X-ray, especially with kind of the portable equipment, yes, I think there is a lot of room to develop for that equipment to get smaller, less dense, and then also to be more accessible and also to have higher penetrative capabilities.